Hi everybody, and welcome to our last video for Unit 10. Today we're going to talk about two things. One thing is actually going to be about going backwards. So we're going to do something called inverses to find the angle measures now. And then the second thing we're going to talk about is how do we know for sure when to do something like a sine, a cosine, or tangent, or when should we just be doing the Pythagorean Theorem? So moving on, let's start with our first topic. So the first thing we're going to talk about right here is using trig ratios to find angles. So what we're going to need for that is to know where the inverse keys are on our calculator. Because what it says right here is if you need to find an angle on a right triangle, you can use the inverse of a trig function. So just a little background on that. When you talk about inverses in algebra, you kind of talk about the reverse. So for example, what went in is now what's going to be coming out. So let's just clarify that a little bit more. So when we did our trig functions, we would type in sine and then an angle and hit enter. Well, that decimal we got was the ratio of the two sides being over top of each other. So that was the decimal of those two sides being divided. Now what's going to happen is we're going to, in our calculator, press these buttons, put in the fraction or the decimal of the two sides, and the calculator will then give us the angle. So it's going to now go in reverse. So these keys look just like the other keys that we've been working with, except now they've got an exponent of -1. Now it's not a true exponent, it's simply just notation to let us know that we're talking about the inverse. So if you kind of see through, if we're talking about sine, we'll have the little -1. Now, depending on your calculator, they might call it the arc sine. That was something that kind of came up a while back. All right, so if you're using a calculator, you could have a key that maybe looks like that, or perhaps over top of your sine key, it might say that instead of this. So if you have this on your calculator or whatever device you're using, that is exactly what we want. That is the inverse. And then same thing, here's our cosine. Again, with the -1, that means inverse cosine or arc cosine, which, depending what you're working with, you may see this on your calculator or device. And then last but not least, the inverse tangent or the arc tangent, which would look like this. So depending again what you're using, you may see the -1 as the exponent. You might actually see like INV tangent, or you could see it looking like this where it says arc sine, arc cosine, or arc tangent. So just some sample calculators that you may be working with to kind of give you a better heads up on where these keys are. This is an iPhone turned on its side, so that way the calculator is expanded. First and foremost, if you are using an iPhone, then you will have to hit this second key first. And then what happens is your trig keys here end up switching to the inverse trig keys. So as soon as you hit this second, your sine, cosine, and tangent will now all have the little -1 up top. Make sure that when you're using these inverse keys, you are doing these three here. These three underneath here with the H, something completely different, okay? Other calculators that I know that some of you guys might be using. On here, the left one is a typical TI scientific calculator, which again, you will have to hit second first. The second key is up here. This kind of looks a little bit, well, exactly like the graphing calculators we were working with in school. And then you'll go ahead and hit sine, cosine, or tangent, which will bring up these buttons or these labels that are over top of the buttons, which will see have the little -1. Now, it might not be a Texas Instrument, a TI, you might have a Casio, you might have some other type of calculator, but again, if it has a second key, chances are the inverse is right over top of your traditional sine, cosine, tangent. And then I was looking at a regular just computer calculator, and I noticed that what mine was doing, which might be what your cell phone does or your computer does, is instead of having a second key, it has an arrow key. So if you see an arrow and not second, then go ahead and press that, and then what happens is right up here, you'll see that we get all those inverse functions that we're talking about, okay? So now let's talk about how we're going to use them. So when you get to a problem that asks you to find an angle, okay, we're going to do the first thing we've been doing for all of this trig stuff. We're going to label the sides of the triangle and decide which function to use. Again, this is where SOHCAHTOA comes into place. Of course, the SOH, S-O-H, is your sine, being the opposite over hypotenuse. The CA, which is your cosine, which is the adjacent over top of the hypotenuse. And then the TOA, which is your tangent, telling us that it's the opposite over adjacent. You're going to write your trig equation just like you always would, except obviously you're not going to have the angle, so you're literally just going to put an A in for the angle. And then whatever the numbers are that you have in the problem, you'll put it over top. So your equation could look, for example, something like this. Sine of A equals, and then again, some number over some number, okay? Again, just to clarify, these are number symbols, they're not hashtags. And then in your calculator, what will end up happening is you'll use that inverse trig, which in this case would be the sine with the -1, and then you're going to go ahead and type in that fraction. So we've got a couple of examples on the next page for you to clarify this. Okay, so our directions tell us to use the inverse trig ratio, or n inverse trig ratio, to find the missing angle. And this time we're just going to round to 1 decimal place, okay? So if we take a look at our first one, we have a house that is 14 meters tall. So I know the 14's over here looks a little awkward. If you want to kind of draw it in right in there, that's fine. Okay, but basically what's happening is you've got this 14-foot tall house, and it's casting a shadow of 22. So notice that we have both sides of the triangle, but what we don't have is that angle of elevation of the sun. Again, angle of elevation basically means if you're looking at the ground here and then you slowly look up to the sun, that angle formed coming up is your angle of elevation. All right, just like we do any of our other trig problems, let's identify where that right angle is. The right angle, again, points straight to the hypotenuse, so we know that that side of the triangle is the hypotenuse. And then looking from where the angle is that we're trying to find, all the way opposite of it, right here, will be the 14. The guy closest to it, the adjacent, will be the 22. So it looks like, based on the information that we actually have, we've got our 14 on the opposite side. We've got the 22 on the adjacent side. So based on SOHCAHTOA, that will be my TOA. The tangent is the only function that is using both the opposite and the adjacent. So we will do tan. Now we don't have the angle, we're just going to put A because that's the letter that they use for the angle there. And then opposite, which is 14, over the adjacent, which is 22. So what you're doing from here, guys, is basically, instead of having an angle to put in and solve the equation, the only thing we really have is this fraction. But we can't just hit the regular tangent key, because when we hit the regular tangent key, it expects an angle. It doesn't expect some weird fraction. So that's why we're going to do the inverse. So what this means here is that we're just going to simply type in our calculator the inverse, so we're going to need that -1 there, and then in place of an angle, we'll go the 14 over 22. Now, I don't even bother typing 14 divided by 22 and getting the decimal and then plugging it in. I just go straight for it, okay? So we're going to go ahead, again, the inverse tangent is the one that's after the second. So I'm going to have to hit the second key and then tangent, and then 14 divided by, because we know a fraction bar is just fancy for division, 22, enter. On your calculator, you should get 32 point, and then if I'm rounding properly, I'll get a 5. So our angle A is going to be equal to 32.5 degrees. Now let's say you do mess up, you forget about this inverse tangent stuff. Well, if I hit the regular tangent and then 14 divided by 22, I get 0.011. So super tiny. And hopefully at that point you'll stop and say, wait a minute, that's not reasonable. Is it reasonable that this angle is 0.0 something? So if you do accidentally hit the regular key, chances are you're gonna notice, whoa, way too small. Not a typical angle that Miss Miller has been giving me. Let me try again. And that's when hopefully you'll remember that we want that inverse key. All right, let's move on to number 2. Number 2, we've got a 15-foot ladder and it is leaning against a wall. So here's our ladder, here's our 15-foot. The base of the ladder is 3 feet from the wall, right here, and we want this angle measure here. All right, again, a wall stands straight up and down, so here's our 90 degree. Across from the 90 degree is the hypotenuse, so it looks like the 15 is our H. According to where that angle is, his opposite would actually be the wall. His adjacent is that distance, the basis from the wall. So again, deciding on our trig function, we know that we can only use the sides that actually have numbers or variables on them. So in this case, it is the A and the H, that's the A. And if you remember what our big bad Philadelphia Eagles say, ka, ka. So that means we're going to be using the cosine. So we're going to go ahead and write our equation. We'll have cosine cos A equals our adjacent, which is 3, over our hypotenuse, which is 15. So in order to get that angle A, we're going to have to use that inverse cosine, and put the 3 over 15 inside. So again, don't forget, no matter what calculator you're using, there'll be some sort of second key or maybe an arrow key. So second, and then cosine, and then typing in the 3 divided by 15, we will get 78.5. That is 78.5 degrees. Again, just to double check, if you forgot the regular cosine, if you forgot the inverse cosine and you use the regular cosine, you're gonna get 1, okay? There's no way this ladder is only off the ground 1 degree, okay? You ain't climbing very high if it is, okay? And last one for this, a ramp has a length of 28 feet. At the end of the ramp, the height is 5 feet. So basically, the ramp ends here, and it is 5 feet up. And we want to know what is this angle of elevation. Again, elevation, because from down up is your angle of elevation. So basically, what's the steepness of this ramp? Okay, if somebody's got a wheelchair, or they're pushing up like furniture on a dolly, is it going to be too steep for them to actually be able to easily get it up there? So again, looking at our right angle, across from the right angle is the hypotenuse. Taking a look at our angle A across and here. So this is our opposite, this is our adjacent. Based on what we actually have numbers on, that would be our opposite and our hypotenuse, which means that we're using the so part of our SOHCAHTOA. So that means we're going to use the sine of A equal to 5 over 28. Again, because we're looking for the angle and not one of the side lengths, we're going to use the inverse. The inverse allows us to reverse what we put in the calculator. It allows us to type in the ratio of the sides to then get the angle out. So we're going to do our second sine, 5 divided by 28, and that will give us 10.3 degrees. Now, definitely smaller than the other two examples that we had. However, it does make sense that we can't have something, too high, or we wouldn't be able to wheel anything up there, okay? So this is how we find our angle. So if you're asked to use an inverse function, again, make sure you're getting the key that has the little -1, and then go ahead and type in your ratio of the sides. Remember that a fraction bar is really just division. And then for these, I'll always tell you to round to 1 decimal place. The last thing we're going to talk about is really just making sure that we're pulling everything from this unit all together. So instead of just asking you about the trig functions, I just want to make sure, are we clear as far as what's the difference between using the Pythagorean theorem and a trig ratio, okay? So just questions to ask yourself. Number 1, am I given a right triangle with 2 known side lengths? Okay, so you're given one of these problems, I'm talking about, trees and ladders and everything. Well, look at the information given, okay? If you're given 2 known side lengths, meaning you actually see 2 sides, okay? And 2 sides have numbers typed on them, okay? If actual numbers are typed onto 2 of the sides, and I'm asking you for this third side, then yes, use the Pythagorean theorem, okay? So for example, if I was doing this problem, I would know that I'm using the Pythagorean theorem, which is a squared plus b squared equals c squared, okay? Remember that across from your 90 degree will always be the hypotenuse, which is always the c. So I know that 25 will go in the c position. And as far as the legs are concerned, the sides that make up the right angle, it really doesn't make a difference who's A and who's B. That is completely up to you. So plugging it into the Pythagorean theorem, we get a squared plus 24 squared equals 25 squared. 24 squared will give us 576. 25 squared will give us 625. Remember, since your variable's on the left, you're going to have to subtract the 576 first. That will get your x squared all alone. When we subtract these two, we'll get 49. And when we use the Pythagorean theorem, remember that your very last step is going to be to square root so that you can get just x. And in this case, our answer is 7. So if you have a looking triangle like this, you're given 2 numbers on the sides, and then you're missing that one side, then you're using Pythagorean theorem. But what about number 2? Am I given a right triangle with only 1 known side length and 1 known acute angle? So now when I look at my picture, I only have 1 side that has a number on it. However, to make up for that, I'm also given an angle inside the triangle, other than the 90 degree. If that's the case, then we're using the trig. So if you take a look at this problem here, again, here's that 1 number given for that side length here. And then here is that angle. This is the side I want to find. If this is the case, then I know I have to use trig. To solve this, again, make sure you're labeling all your sides. So across from the 90, that will be your hypotenuse. Then looking at the angle that's given to the other 2 sides of the triangle. Since this side here had the longer arrow, that's your opposite. Here's your adjacent. Again, as a quick recall, I can only use the trig function that's going to use the two side lengths that have something on them. So in this case, I have to use whatever trig function uses the opposite and the hypotenuse. In our SOHCAHTOA, that is the SO. So we're going to do the sine of 16.3 degrees equals x over 25. The sine of 16.3 is going to give us approximately 0.2807 over 25. Put that decimal over 1 so it just looks like a regular proportion. Cross multiply, x times 1 is x, and the 0.2807 times 25 is approximately 7.02. So of course, based on rounding, we didn't get the same exact number as we did up top. However, you can see that we do have two different cases with the same triangle. Again, this top one meaning we'd have to use Pythagorean Theorem, and this bottom meaning we'd have to use the trig. So on the next page, I just have two more problems for you. One that's going to use Pythagorean Theorem, and one that's going to be using trig. And let's just make sure that we're clear on which one needs to go with what. So if you notice the directions, use the Pythagorean Theorem or a trig equation to answer each question. So if we take a look, I pretty much use the same picture just like I did on the other page, but I switched things up a bit. So for number 4, it says that a 24-foot long bleacher stand, so this is the bleachers, has a base angle of 30, and I want to know what is the horizontal width of the bleacher. Over here for number 5, we have the same 24-foot long bleacher. Now we're talking about it having a horizontal width of 18, and now I want to know, well, how high above the ground is that last row? So again, thinking about the questions from the other page as far as, well, what am I given? In the first one, I'm only given one number for the sides. However, they also give me one angle. So if we remember, when we're given one side and one angle, that means we're going to use the trig. And just as a quick review in deciding from your SOHCAHTOA what to use, your 90 degree, well, that would be right here. Across from the 90 is your hypotenuse, so it looks like we've got the hypotenuse that we're going to have to use. So that means we're going to have to be using either sine or cosine. Okay, tangent does not use the hypotenuse. And then based on where the angle is here, all the way across here would be your opposite. This guy would be your adjacent. So if you notice, we've got the number 24 on the H, so I know I need to use something with an H. I've got the X where the side is the adjacent, the A. So that tells me I'm going to have to use the cosine, because in SOHCAHTOA, the cosine reminds us that it is the adjacent over the hypotenuse. So we'll do the cosine of 30 degrees equals x over 24. The cosine of 30. Now remember, guys, now that we're actually plugging in the angle into these problems, I'm not using that inverse key right now. Now I'm just using the regular cosine key. And that will give me 0.8660. Now the good news is that, let's say you're getting confused. You're like, wait, you just mentioned the inverse and now we're going back to the regular. If you did make a mistake and do second cosine and put in 30, it's going to give you an error, because we know that when we get this fraction, it can't possibly be bigger than 1, okay? So if you end up getting an error when you type something in, then chances are you might be using the wrong key. So remember that when we're just regularly solving the equations for one side of the triangle and we've determined it needs trig, make sure you're using your regular cosine, sine, and tangent buttons. So to finish this problem out, we've got 0.8660 times 24. and that will give us an x value of about 20.78 feet. So again, we used trig for this equation because on the beginning picture, they only gave me one number on the side, so it gave me one side, and then it gave me one angle. For number 5, notice that they're not giving me any acute angles inside the picture. All we really know is that it is a right triangle, but as far as what they're giving me around the outsides here, they've just given me the 24 here and the 18 here. So unlike number 4, now I have 2 sides. Well, if I'm given 2 sides, that will always be your Pythagorean theorem. So again, looking as far as who's across, notice that the 24 is your hypotenuse, so it looks like, just like on the other page, we're gonna have to make sure that that hypotenuse goes on its own side there. That'll give us h squared plus 18 squared. All right, 18 squared, if we don't have it memorized. Obviously that's not me at this time. Quarantine has fried my brain. All right, 18 squared is 324. 24 squared is 576. Again, make sure that we subtract the 324 from both sides. So 576 minus 324 is giving us 252. When we square root the 252, the height is 15.87 feet. So again, we use Pythagorean theorem with number 5 because we were given 2 side lengths. Whereas for number 4, we used the trig, in particular the cosine, because they gave us an acute angle and they gave us the hypotenuse. And this is the last section of notes for Unit 10. So our goal is to be finished with this unit by the end of the week, okay, by Friday, May 1st. And we'll give you a few days break and then we'll get started with something else, okay? Please let us know if you're having any trouble whatsoever. Again, devices, calculator, squaring, cosine, inverse cosine, whatever the case may be, please make sure that you reach out to me through the Remind app or through our email so I can help you out as best I can, okay? Good luck, and I'll talk to you later. Bye-bye.